problem number 7 of additional practice condensing logarithms. And once again, we're still looking. We're looking for the operations. We're looking at whether we have a coefficient on any of our logarithms. And in fact, as I glance at problem number 7, that's the first thing that I notice, is that there is a 2 in front of the logarithm. So I'm going to leave log of x alone, plus log of x squared minus 16. I'm going to take this 2 and make it an exponent. So it's minus log of x plus 4 squared. As I go back to the beginning of the problem, I see that there's a plus, so we're going to use the product property of logarithms. And we're going to condense this by multiplying x times x squared minus 16. And then over here we have log of x plus 4 squared. And we're subtracting, so subtraction means that we're going to use our quotient property of logarithms. And when we subtract, we still are going to have our x times our x squared minus 16. But now we're going to divide by x plus 4 squared. And all of that is our logarithm. So we have this down to one logarithm. But if you recall from the directions, we need to simplify completely. And we can do some more simplifying on this problem. So I'm going to ignore the word log for a moment. And I'm going to expand this out, and actually I changed my mind. I'm going to write log, and I'll leave my green parentheses here. But what this turns into is x, and then we're going to factor x squared minus 16. It's the difference between two squares, so it's x times x, and 4 times 4, in different signs. As I expand x plus 4 squared, what that means is it means x plus 4 times x plus 4. Now what we're looking for is, do we have anything exactly the same in the top and in the bottom? And what we see is that there's an x plus 4 here and an x plus 4 there. And now that we have that, we're again simplifying. We want this in simplest form so we can finish with x times x minus 4 divided by the x plus 4. Again, our goal in condensing is to make sure that we end up with just one logarithm. Problem number 8. I see the plus in here. But one thing that I might consider dealing with, might leave this log of x to the 7th, and not might, as I stand here right, but let's rewrite the cube root of x to the 4th without a radical symbol. And if we do that, remember that the number in the check mark part of the radical, which is the 3, goes in the bottom of the fraction, and so this is x to the 4/3 power. And now what we have is we have a plus in this problem, so we're going to use the product property of logarithms. We're going to multiply x to the 7th times x to the 4/3. But when we multiply terms with exponents, that means that we add the exponents. And once again, if you need to, you pull up your calculator and you say 7 plus 4/3, and we get 25/3. So this simplifies to be log of x to the 25/3. If you're doing this problem by hand, you would have to find the common denominator. But once again, with the directions say express powers of as factors if possible. And it is possible. I'm going to take this 25/3 and we're going to write it back here as a factor. So our 25 thirds is going to be coefficient on our logarithm. It's 25 thirds times log of x. Number 9. 2 log base 2 of x minus log base 2 of x minus 3 plus 5 log base 2 of x plus 7. Starting once again with our power property of logarithms. And on our first term here, we're going to rewrite this one as log base 2 of x squared. I'm not going to do anything with log base 2 of x minus 3. But then we have plus 5 log base 2 of x plus 7. So I'm going to rewrite this as log base 2 of x plus 7 to the fifth. And now we can work with our other properties. Going to deal with the first two terms. It's log base 2 of x squared minus log base 2 of x minus 3. So we're going to condense it down. It's log base 2 of x squared divided by x minus 3. The minus sign in there tells us to use the quotient property of logarithms. And we still have over here the log base 2 of x plus 7 to the fifth. Well, now, let's deal with the plus. We're going to use our product property. So we have x squared divided by x minus 3 multiplied by x plus 7 to the fifth here. And there's actually, I'm going to write it a little bit better, but there's actually not much else we can do with this problem. We've dealt with all of our properties, and we end up with log base 2 of x squared times x plus 7 to the fifth. If you need, remember it's x plus 7 to the fifth over 1, so we're going to multiply the tops of the fractions and the numerator together. And down here we're going to multiply the denominators, the bottom of the fraction. X minus 3 times 1 is x minus 3. And our goal when we condense logarithms is that we're able to write the entire problem as one logarithm. So log base 2 of x squared times x plus 7 to the fifth power, all divided by x minus 3. Number 10. Hopefully by now we're getting the hang of things, but we see the fourth root of x, and we need to rewrite this. We're going to write it as log base 8. And remember, it's going to be x. The number in the checkmark part goes in the denominator, the bottom of the fraction. So it's x to the 1/4 minus log base 8 of x to the 9. Well, minus means divide. So we're using the quotient property of logarithms to condense this down into log base 8 of x to the 1/4 divided by x to the 9. And we can simplify that more. So remember, when we divide, we subtract exponents. And Mrs. Krause might do this just slightly different, but I like to subtract the top minus the bottom. So 1/4 minus 9 to combine. X to the 1/4 divided by x to the 9. 9 means the same thing as x to the 1/4 minus 9. Worst comes to worst, we pull out our calculator, we type in 1/4 minus 9, and we get negative 35/4. Log of x to the negative 35/4. And we actually only need to deal with one more step here. Again, a reminder, express powers as factors if possible. And it's possible. You're going to take that value, you're going to write it out in front. And we end up with negative 35/4 times log of x. Problem number 11. We have natural logarithms in here, but natural logarithms and common logarithms, the properties still apply, regardless of which one we have. So the first thing that we notice on this particular problem is that we have this 5 out here in front. So we're going to have the natural log of x plus 3 to the 5th minus the logarithm, the natural logarithm of x squared minus 9. Well, our goal is to turn this problem into one logarithm. So we're going to have the natural log of x plus 3 to the 5th divided by, and we're dividing because there's a subtraction symbol in there, x squared minus 9. If we take a closer look at this, what we see is that the denominator, the x squared minus 9, we can factor that. So this becomes the natural log of x plus 3 to the 5th. And when we factor down here, this becomes x times x, 3 times 3, difference between two squares and different signs. And now we want to take a look and see if we can simplify that any more. Well, I hope that you don't have to do all of this, but I'm going to do it anyway. X plus 3 to the 5th power means x plus 3 times x plus 3 times x plus 3 times x plus 3 times x plus 3. And we're dividing that entire numerator, the top of the fraction, divided by x minus 3 times x plus 3. And as we take a closer look and we're looking for, do we have anything exactly the same on the top and the bottom? Well, one of those x plus 3 is going to cancel out. And what we can do here to finish this problem, or at least get close, is we're left with 1, 2, 3, 4 x plus 3s. So we've got x plus 3 to the 4th here, and we still have an x minus 3 in the denominator. Again, that's going to apply for the entire natural logarithm. To finish, first things first, let's deal with the square root of x and the cube root of x. Square root of x. Remember that if there's no number written in the checkmark part, it's a 2. So the square root of x is the same thing as x to the 1/2. The number in the checkmark part of the radical is the denominator. It's the bottom of the fraction. Over here with the cubed root of x, we can convert that. And the 3 is going to go in the bottom. There's no exponent written there, so we can assume it was a 1, just like we assumed it was a 1 here. So the cubed root of x is the same thing as x to the 1/3. So to start this problem, we get 4 log of x to the 1/2 minus log of x to the 1/3. We've got the 4 for a coefficient, so we're going to use our power property of logarithms. We're going to take that 4 and we're going to rewrite it as log of x to the 1/2 raised to the 4th minus log of x to the 1/3. We talked about this on one of the earlier problems. X to the 1/2 raised to the 4th means that we have to superpower these exponents there. Superpower means that we're going to multiply those exponents. So we're going to get log of x squared. 1/2 times 4 is 2. Minus log of x to the 1/3. And now we have it in a format where we can use the quotient property of logarithms because there's a minus sign in between these two logarithms. So this becomes log of x squared divided by x to the 1/3. Remember, when we divide terms with like bases here, this would become log of x squared minus 1/3. We subtract the exponents. Again, if you can't do that by hand, then take out your calculator and do 2 minus 1/3, which gives us 5/3. So now we have log 5/3. Oh, and I forgot my x. Log x to the 5/3. But lastly, as our directions tell us, we want to express the powers as factors if possible. So we're going to take this 5/3 and write it out here in front. We end up with 5/3 times log of x. And hopefully, if you've made it through the additional practice here, you will be ready for your quiz on condensing logarithms tomorrow.